Welcome back to Connect and Transform. We are continuing creating a game of checkers. By the end of this video, we will have a functional demo with all game modes working. Human v human, human v machine, and machine v machine should all be functional. One thing I noticed is last time when we were defaulting these values, current turn to red and moves possible to 0, it occurred to me that when checkers is beginning, the number of possible moves is always 7. There's only 4 pieces you can move, there's only 4 squares you can move to, and one of the pieces being all the way on the edge only has 1 move. So we're going to go ahead and just hard code that. There's no point in calculating something that is always a fixed constant. Next is, I realized as I was reviewing some of these functions that where it says moves possible here, that doesn't always necessarily get updated to the correct value. We're using this allowable moves variable, which is in get all moves for all pieces. But the problem is we have this edge case, can continue jump. So if you're in the middle of a jump and you can continue a jump, the problem is we have a special filter on here that is never referred to anywhere in this get all moves for all pieces function. So I don't think that's the right place to be setting allowable moves. So we're going to remove allowable moves from this function. And instead, we're going to calculate it here in the advanced move function. Another thing we're going to do is we're going to limit the number of calls to get all moves for all pieces. We're going to create a variable called possible moves, and that will be holding our initial call, and then we'll refer to that as much as we can in the function here. One thing to take note of is that if turn change does end up getting called, then we do need to call get all moves for all pieces again. Because we're going to be using the possible moves value as our default, we're going to be setting the allowable moves, which is the one used on the informational display here. We're going to be setting that in this function, and we're going to default it to possible moves.length. There is one condition where allowable moves will not equal that, and that is when you can continue a jump. And then in that case, it's going to be equal to this special filter dot length, because allowable moves is an integer, so we're making sure to put dot length on the end. And we've already updated possible moves the second time, so that's valid. So, and we need to make sure that this is an assignment, okay, to allowable moves. So now that should be good to go. The other thing that I noticed is in this special case scenario, we might be making a call to auto move. And the problem with that is that here in the auto move function, we're just calling get all moves for all pieces. So we have a very similar issue. So what we need to do is in this very special scenario here, when we call auto move, we need to basically insert an optional parameter. So I'm going to just take the allowed moves and just pass that in. And so the thing we're going to pass in will be this possible moves dot filter. Okay. So basically we're optionally passing in some moves to auto move. Okay, so we're going to make that a variable, and then we're going to say if moves exist. Then we're going to override possible moves with the ones that we specifically passed in. Another thing is, as we continue with the UI interaction, it's going to get tricky to use the selected piece because different animations are going to be delayed and time delayed and stuff. So for the king.me function, we're going to pass in a specific string, and we're going to change the king.me function to expect an ID. And so that's going to be from the move that we have access to in this function. That's going to be old move dot destination. Now, in this case, the destination is the ID of a board square rather than the ID of a piece. So first, let's make sure we are passing in an ID and that we're making use of it instead of the selected piece. And then we're going to need to modify the king.me function just a little bit more. So here we're going to make sure to get the right ID first. So we're going to get a piece from board square, and it doesn't matter, but like if this ID was already a piece ID, this function would still work and it would not have any net effect. And so we're going to get a piece from that board square, and then we're going to get the ID from that piece. Yeah, I think that's all we're doing there for the time being. So the next thing I wanted to do is, for the move functions and the king.me functions, I want to track the rotation of the pieces, and I want to advance that by a certain amount so that every single move and every single king.me function actually rotates the piece, and it's not 50% of the time or something like that. So we'll start with move piece northwest. So what we're going to do here is we're going to create a variable called rotation. We're going to default it to 180 because that's what we're using in our animation right now. We're going to go over here, we're going to get rid of the 180, and we're going to use rotation. And then basically we want to check if it's already been rotated, read back that value using a regex, advance it by some amount. So that's what we're going to do here. So we're going to say if current piece get attribute style, because style is the attribute that we're setting with our transitions. So we want to make sure that we've already executed one transition before attempting to shift the rotation from anything other than its default of 180. And then there will be an additional condition. We're just going to do a sanity check, and we're just going to make sure that the style attribute with reasonable certainty has already set a rotation. So we're going to say index of not equal to -1. So we're going to make sure that it contains the text DEG closing parentheses. It's not ironclad, but it's pretty certain. Now this line, so if we've already set a style and there's already a degree component to it, then we're going to look at assigning a new value to the rotation that's different than the default. So this will be an assignment. And we're going to be looking at basically this parseInt is going to be a regex extraction. And then we're going to add 180 to it. And then we're going to modulo 360. Okay, so we're going to extract an integer. So that integer, we're going to grab the style component, and then we're going to say dot match. We're not going to use the G flag. We know we're going to be getting index 1 because we're going to specifically encapsulate the numeric component in parentheses. So what is it that we're matching? Let's scroll over here. Specifically, we're going to be matching where it says open parentheses, some amount of digits, DEG, closing parentheses. So we need to escape our open and closing parens, and then DEG before that, and before the DEG, there's going to be some numeric component. And this is the one that we want to encapsulate in unescaped parentheses. And it will be a series of one or more digits. Okay, so let's copy this to our other move functions and also to king me. And then we're going to update references that currently say 180 to use the rotation. So that's our 4 move functions. We'll scroll down. And then this is our king me function. So we're changing the degree of rotation a little bit. It used to be 90. Now we're saying 180. I could change that to 90 if I wanted to. I think for now, I'll just keep it at 180. Okay, so now we've kind of dealt with some of the nitty-gritty details, and now we're down to the final couple things. We need to add 4 event listeners, and all 4 are going to be in these 2 functions. We're going to have 3 event listeners on the pieces that we're generating and 1 event listener on the board square. So on the piece, we're going to have mouse over, mouse out, and click. And then on the board square, we're going to have click. So the idea is that mouse over and mouse out will just give you a very subtle color change, probably on the board square underneath the piece, just so that you can see whether or not a piece is selectable. And then when you click on a piece, that will actually select it, and it will highlight and accentuate which board squares are valid destinations. And then when you click on a board square that is a valid destination, then we'll be able to actually execute a move. So let's begin with our first event listener. We'll say piece.add event listener. And this is going to be on the mouse over action. And it will execute a function. Now, we don't want any piece to do something when we mouse over it. We only want to touch the pieces that are allowed to move that are on our own team. So there will be some condition. Okay, so what is that condition? How do we determine which pieces can be moved? We're going to get all moves for all pieces to start with, because that will automatically limit us to valid moves for our own team anyway. And then we're going to do some kind of filter. And then we're going to check that the filter has results. Okay, so the filter is basically going to check that the source of the move is equal to the current ID. So move.source equals this.id. So this entire line is basically saying, is it acceptable to move this piece? Okay. And then we have one other condition. We don't want to do anything here if this piece is already the selected piece. So we'll say if this dot ID is the selected piece. Actually, we're going to say the opposite. We're going to say if it is not the selected piece, then we're going to be doing something with that piece and its board square. So from here, what we're going to do is we want to get the board square from the piece and then set the fill attribute. And I'm recalling that we wrote this function in a previous video, very similar to this one here. And I think I removed it believing that we would not use it. So we're going to reconstruct it here. So it's going to be called get board square from piece. And it's basically just a query returning items where the ID begins with B at the same XY position as the piece. So there we've reconstructed that function. So now we can call it. And that will be using the current ID of the piece that we just moused over. So we're getting the board square at the same XY coordinate as that piece. And then we're going to set attribute. Set the fill attribute to a color. Now by default, the gray-blue square has the color 789. So I'm going to just do 987, which would be mostly red, a little less green, and less still for blue. Let me go ahead and save, and we'll refresh and do a quick demo here. 365. Let's see what I did this time. Oh. Okay. 381. Oh, that same error got copied and pasted. Okay. I believe there was 5 total instances, 4 on the move functions and 1 on the ping me. Save, refresh. Okay, so there's no errors. And we can see that when I'm hovering over these gridlocked red pieces that are not allowed to move, nothing's happening. I hover over the empty squares, nothing's happening. I hover over any of the black squares, nothing happens. But when I hover over these front row red pieces, they are now highlighted in a way that we can see. So that first event handler, event listener is done. So let's do the second one. So the second one will be for mouse out. And for this one, we want to be a little bit less restrictive because we do want the color to go back to the blue-gray under just about any condition except when this is the selected piece, then we don't. And so here we're restoring the color back to its original 789. So I'll save that. Let's refresh over here. And so now we see when I hover over a movable piece, the color on the board square changes. And when I move the mouse out, it changes back. So now we've got 2 of our 4 event listeners done. Let's look at the final event listener for the piece. That will be on the click action. We're going to keep this first if statement that basically requires that the piece be a movable piece. And then we're going to have some stuff that we do. So when we click on a piece, we're going to toggle a class name to be present or not present. So the piece's class name will be selected. And then when we click on a destination board square, it will have a special class name called destination. So both the piece and the board square each kind of have their own special class name to keep track of state. So we're going to say if this class list does not contain selected, not. Okay, so if the class list does not contain selected, then we're going to select it. Otherwise, we're going to unselect it. So for this, we're going to create 4 more functions. So we're going to have a function called select piece. So it's not going to be select ed piece, which is an ID. It's going to be a function called select piece, and that's going to take the element itself. So we'll say function select piece, which takes an element. And then we're also going to have a function for unselect piece, which takes an element. And then, in addition to selecting a piece, we're also going to highlight valid destination board squares. And for this one, we'll just pass an ID. And then correspondingly, we will have an unhighlight valid destinations. Okay, and this one takes an ID. Okay, so we will get back to these four functions here. But first, I want to finish the final event listener, which will be on a board square. So that will be on the square, and it's on the click action. And so here, basically, we're going to say if it contains its special class name. So if this dot class list dot contains destination, and so this is basically saying that we only want to execute whatever's in here if the board square that we click on is a valid destination for the currently selected piece. And so what are we going to do in this case? Well, we're going to unhighlight any existing items, and that takes an ID. And then we're going to execute a fifth function that we need to create called move to. And so this one's going to take a source ID, which is a piece, and a destination ID, which is a board square. So in this case, the destination ID is going to be the current ID. And then this will just be selected piece. And then after we've moved the piece, then we're going to unselect it. And this one takes an element. So we'll just query by the selected piece, which is an ID. And that is the entire event listener there. So all of our event listeners are created. The only things we have to do now is finish these four functions as well as the move to function. Let's do the move to function real quick. Okay, so I'm going to put it right there because basically the move to function is going to be analyzing the XY positions of the two IDs. And from the distance and direction of those XY differences, that's going to determine which of these 8 functions gets called. We're going to construct a move, and then we're going to call apply move and give it that move. So function move to, which has a source ID and a destination ID. So we're going to have a source X, which is going to be from the source ID. And then source Y is also a substring of the ID And then we're going to have destination X, which is a substring of the destination ID. And same with destination Y. And then we're going to build a move action. We'll start out with it being empty. We're going to have a number of conditions where we're comparing the X and Y coordinates. And then, like I said, selecting which of these 8 gets put into the move action. So we'll get back to that in a moment. And then we're going to construct a move, which is an object that contains a source. And the source will just be the source ID. It contains a destination, which will be the destination ID, and it contains an action, which is the thing that we now need to set to the right value. And then we're going to call this apply move function with the move that we've just constructed. So now we need to compare the X and Y coordinates. Okay, so we're going to say if the destination X minus the source X, and I'll just pick -2. I could have picked any number there to start with. Got to start with something, and then we'll say destination Y minus source Y. We're basically saying that the difference in the X coordinates changed by -2 and Y by -2. So if both X and Y are negative with respect to the top left corner, then you're moving to the top left, which is northwest. Now in this case, the unit quantities are -2 and -2, so we know it's a jump. So that's a jump to the northwest. So move action equals the string jump piece northwest. And then when we call apply move, it'll execute this switch and it'll actually make the function call here. So this is 1 out of 8 conditions. So we're going to keep the signage the same, but change the unit distance to -1, -1, which is still a northwest direction, but it is now a move instead of a jump. So now we've done 2. Okay, so now we're going to keep the negative for the X, but we're going to change the Y's to positive. So if your X is becoming more negative, but your Y is becoming more positive, then you're moving to the southwest. So change those 2 to southwest. Done with 4, we got 4 to go. So now we will say that the X is positive and the Y is negative. So if X is positive and Y is negative, that would mean you're moving to the northeast. And then if it's positive and positive, then you're moving to the southeast. Okay, so move to function is done. All we need to do now is finish these 4 functions. Let me go ahead and save. I'm just going to refresh and make sure I didn't do any more typos. Okay, it looks okay. Mouse over is working, mouse out is working. Click isn't going to do anything yet because we haven't implemented these functions. So one thing to keep in mind is if we click a piece and then click it again, we want to kind of toggle back and forth. So we'll kind of keep that in the back of our mind. So when we select a piece, the first thing we're going to do is we're going to say if the element does not have the class name selected, then we're going to add that class name. So if not lm dot class list dot contains selected, then lm dot class list dot add selected. And then the next thing we want to do, we want to get our X and Y coordinates from the ID because we need that to be able to properly translate the piece's position before we zoom it in or scale it from like 1 to 1.1. I just want a very subtle zooming when you click on the piece. And so that's going to be parse int, and we're getting the ID, so that'll be lm.id.substring 2, 3 for X, 4, 5 for Y. Okay, so we've got our X and Y at our disposal now. And so like I was mentioning before with the toggling, if we've previously selected it, then we're going to have a style attribute set. And so then if we're going to toggle it back, all we have to do is basically read back the style attribute and just do a string replace on the scaling portion. So we look for an instance of scale 1 and we change it to scale 1.1 or whatever. So we're going to check if the style exists. If it doesn't exist, then we're going to set it. And I think I'm going to just copy another line here. Okay, so if the style attribute does not yet exist, then we're going to set it. So that would be lm.setAttribute style. And we'll be setting it to some value. I think I'm going to make it a very quick transition. And remember, we're not adding this to the transition queue. We're setting the style directly because we don't want to be delaying this. We just want it to happen. We already have our X and Y. And in this case, because we're setting the initial value, we're going to scale it to 1.1. And we're not going to have any rotation in that action. Now, if, on the other hand, the style attribute already exists, then we're going to set the style a slightly different way. And so the value that we're going to set will be lm.getAttributeStyle. And we're going to replace okay. Then the other thing we want to do is we want to make sure to set the selected piece. So if the selected piece is already present, then we'll want to unselect it. And this takes, I believe, an element. So we're going to have to do document query selector selected piece, okay? And then selected piece equals this dot ID. So yeah, if we're selecting a current piece, we got to check and see if there's already a selection. If so, we unselect it, and then we update the selected piece to our own ID. Let me just save that real quick. We'll refresh over here. So if I click this, we saw it got bigger. And if I click this, it gets bigger. Now I'm not unselecting any pieces yet, so it only gets bigger and it never really it never gets smaller again, but it will once we implement the other three functions. So let's go ahead and do unselect piece now. So the first thing we're going to do here is we are going to remove our special class name of selected. We'll just say lm.classlist.remove. Okay, so we're going to remove from the class list the item selected. And then we want our X and Y to be available because we're going to be changing the scaling back down. And actually here, we want this to, when we're selecting a piece, we want it to end up with a scale of 1.1. So I had swapped the ones and the 1.1s. I'm going to copy this bit of code here. And so in this case, when we're unselecting a piece, we want to look for any instance of 1.1 and change it to 1. And if we haven't yet set a style, then we would just want to make sure to scale it to 1. And then the other thing we want to do, which is kind of in line with what this function is doing, is we just want to say that the selected piece equals false. Okay, let me save that. Let's go back over here and refresh. So I'm going to select that piece, and then I'm going to select this piece, select this piece. Okay, so it's close. So we can see that we can toggle the same piece in and out. It's not quite working when we're selecting other pieces. I'll have to think on why that is, because I would think that selected piece would exist and then we're calling unselect piece. We'll get back to that later. So let's look at highlight valid destinations. So first of all, we're going to make sure that everything starts out unhighlighted. And then we're going to get all of the valid moves because we want to highlight the squares that are valid destinations. And so we're going to start out with get all moves for all pieces. We're going to apply a filter to it. And that's going to be where the moves source is equal to the ID, because we are highlighting valid destinations for a source ID. Okay, and then once we have all of our allowed moves, we're going to say if allowed moves, if there's more than one, more than 0. So if allowed moves dot length is greater than 0, then For each of them, okay, so for each of them, we're going to run an anonymous function. And we're going to get the board square. And we're going to add the class name of destination to it. And then we're going to make sure to change the coloring, the fill of it. So we'll say board square equals, and this is going to be from the move, it's going to be the destination, right? Because if we're clicking on a piece, then we're clicking on a board square to move the piece to. The board square represents the destination. So now we've got our board square that we can access. So we're going to set the fill attribute. And I chose a green color because the board already has whites, blacks, reds, blues. So greens and oranges are pretty much all that's left. So I've written down a color here, 9C2, which I believe is like a lime greenish color. We'll see in a moment in the demo. And then we're going to add our class name if it doesn't exist. So if not board square dot class list dot contains destination, then we're going to say board square dot class list dot add destination. And then we are going to get the board square from a piece. So from the selected piece, and then we're going to set that one to also have a special fill value. And I've written down the value of another color, C84. So let me save that. Let's refresh here. So if I click that one, well, that's interesting. Okay, does not contain selected. Let me inspect this. Let's see. So that is selected. Not is not. So that's working. It all moves for all pieces. Oh, I used the wrong term there. Okay, so now when we click on a piece, it's not, okay, it's not on highlighting because we haven't written that function yet. But we can see that it's highlighting the squares in green. We do have a problem there. Okay, let's go ahead and finish our unhighlight valid destinations before we go doing any further debugging. So here we're going to get all board squares that might be highlighted, which is going to be all the dark squares. So board squares, and that's going to be document dot query selector all. That'll be from our board container. And the squares are rectangles with a class name of dark. Okay, so for each board square, we're gonna set the fill. And we're gonna revert the fill back to its original value of 778899. And then we're gonna remove the destination class name if it contains it. So I'm just gonna copy that and we'll modify. So we're gonna be removing the destination class name if it does contain it. Save that, refresh. Okay, so now we can toggle a piece back and forth. Let's see. We can also switch around between pieces. Okay, clicking out here doesn't do anything because it's not a selectable piece. Okay, so we've got some issue on line 103. Okay, so we're saying basically it's saying get board square from piece is being sent something that's not quite a string. So let's see where we're calling that from. Looks like these three places. So this should definitely be an ID. That's definitely an ID. Okay, so here we're saying that selected piece may not exist. Okay, so that should be a fairly quick fix. We'll just validate that the selected piece must exist, but we just selected the piece here. And the selected piece should be set to an ID. Because even if we unselect a piece, we're selecting it afterward. Oh, can't use this. I have to use the element that was passed. Okay. Okay, so I think everything's working now. We can see our yellow color, we can see our green, lime green color, and then if we click on a destination square, okay, so we'll continue our debugging. 573. It says unhighlight valid destinations is not defined. Even though it is defined. Yeah, okay, let me just comment that out and let's see if it's still unhappy. Okay. Unselect piece is not defined. I mean, am I just being dumb? Does it just mean that these have to be higher in the file? If that's the answer, that's really dumb. I mean, I get it, I guess, but I also don't. Okay, so we're on human game mode, so we can click a piece and then we click a destination. Now it's Black's turn, and you'll notice that we can only hover over these 4 pieces that can actually move. So we'll pick a piece, we'll pick a destination, and now we'll notice that because there's a jump available, there's only one red piece that I can hover over, and also moves possible. We're being told that it's a 1. So you click there, you do your move. And now there's 6 possible moves for Black, but there's only 3 pieces that can move. So we get the idea. Human works. Let's click here for human machine. So I'll click a piece, I'll move it, and it should be calling auto move, and it did. I'm going to move that piece there, and it should do the jump. But yeah, this looks like it's working. And then we have machine. So I think I'll end the video by just letting the machine play itself until the game concludes. We'll keep an eye on the console to make sure there are no errors. Well, that didn't go as well as I thought it was going to. Okay, $3.99. So parse int is not defined. That something seems very wrong here. Oh, because it's capitalized. This is the stuff that I really don't like about JavaScript. It's so picky. It makes you choose things that actually exist, that are defined. I'm being sarcastic. Okay, so I've updated those 4. There should be a 5th one here in the kingme function. Okay, we'll save it. We'll go back here to machine. And hopefully this game plays all the way to conclusion. We're taking special note that when a piece can jump, it must jump. And if a piece begins a multi-jump, that same piece must continue. It can't move piece A and then do a different jump with piece B. Also, when a piece becomes a king, even if they could perform a jump, their turn ends. So there, Black had 2 options of jumps, and it chose to jump its non-king forward as opposed to jumping its king backward. And there we go. The winner is Black. I should probably have it now hide this information when there's a winner, but we saw machine play to conclusion. Maybe real quick, I'll just do human machine to conclusion, and then we'll close out the video. So I'm playing red, and I'm really hoping that I win because the computer is not currently playing with a strategy or heuristic that makes any sense. It is choosing a random valid move. So if I lose, okay, I tried to move this piece, but the game was smarter than me because I only have one possible move. And not only that, it's a multi-jump that gets me to a king position. So obviously I'm a little tired from coding and I'm not paying too much attention to the game. think I've played more checkers in the last couple of days making these videos than I've played in the past 10 years. And I get to finish out my win with a king. Very good. Thank you for watching.